We've started by developing drones for seagrass restoration. We've had mechanized farming on land for ages, and we're bringing that to the ocean now. The quickest way to find out is just to ship. The advancements that made batteries so cheap, chemistry and yields, these embedded processors that are super powerful, SIP power. I'm sure you've seen what, FPV drones have done. 10, 15 years ago, the brushless motors for those were really, really expensive, not nearly as performant. And now you can get these amazing motors that cost dollars, not even tens of dollars, but dollars. And that's just a massive opportunity for us.
So my understanding is that you guys are building a underwater autonomous robot that can interact with the environment around it. It's not just a sensor. It also has the ability to do stuff. Can you just tell us more about what you guys have built and what it's doing?
I'm Akhil. I'm one of the 4 co-founders of Ulysses. We founded the company just over a year ago in Dublin, and recently our whole team relocated here to San Francisco. Really excited to be here. We're building autonomous marine drones that don't just look, but can touch. And we've started by developing drones for seagrass restoration. So we've got robots that can go out and see when seagrass meadows are producing seeds, collect those seeds, bring them to what we're calling the mothership, leave those seeds there to be processed, and then the robots can switch out attachments from something that collects seeds to something that then plants these seeds, and then go back out and plant these seeds, and do that all autonomously, and do that all with robots that have a unit cost between 10 and 100 times less than existing ROVs, not even considering existing AUVs, which cost even more than that. And why did we start with seagrass? Well, it's this critical ocean ecosystem, captures 35 times more carbon than rainforest globally, and we're losing it at a rate of 7% every year. And we're restoring it 100 times slower than that, because restoration methods are pre-agricultural revolution. We've had mechanized farming on land for ages, and we're bringing that to the ocean now. But in bringing that to the ocean, we've got this amazing robotic platform and this mothership solution that we know can do so much more.
I think that people probably have no idea what seagrass restoration looks like.
Yeah.
Can you say what is this thing capable of? Is it like you just scoop off of the ground and that's all you need to get the seeds, and you kind of you don't need that much dexterity? Or is it like a pretty dexterous task of opening something and picking it out of it? And then also for the planting side.
There's 72 different species, but the ones that we're working with, it's pretty easy. You've got seeds that grow in spades or fruits that are on the seagrass leaves. Certain species that have spades at the top, kind of like how there are seeds at the top of, a wheat.
Sure, yeah.
You just go and you give it a haircut. You trim the top, and with computer vision, it's pretty easy to identify spade having leaves and non-spade having leaves, so you don't harm the whole meadow, but you just trim what you need, right? And then with other species like what we're working with in Australia, where we have our large-scale pilot coming up in 2 weeks, you've got seeds in fruits, and these fruits grow in little bundles that are coming off the leaf. And if you've ever seen how they harvest olives, right, they just go and they kind of whack the tree with
sure, and just let them fall
with sticks and let them fall. Right now, the divers that go out and they collect these seeds, and it's really, really expensive in terms of manpower. They have thousands of volunteer hours every year to just restore a couple of hectares. They're going and they're waving their hands around in the seagrass meadows, and then they're just the fruits just detach and they go up into a net that they have above. Really easy to automate. We've developed an attachment that mimics exactly what they're doing, but is significantly more efficient and much more effective as well. We just comb right through the meadows and we pick out a whole lot more seeds for a whole lot less time and money.
Totally. And a lot less oxygen that needs to be breathed by the diver.
Yeah, absolutely. Absolutely.
I'm sure that's a big part of it. You probably had to decide and so this is, okay, there are many reasons why I'm really interested in this. One of the reasons is that the requirements of this seem really vague, if that makes sense. There are so many ways that you could go about this. You could maximize for depth. You could maximize for battery life, assuming this thing's electric. You could maximize for precision of being able to pick off just the right, snip off just the right things. There's so many different requirements. So I'm really interested in that. But I'm going to put a pin in that for a second, because I'm also interested in how you demoed it and how you built your first one. Yeah. So as I understand it, you've been working for a year. You already have live customers that you've done projects for. You've already built, and obviously you've already built these things. So like, how do you build it that fast?
The quickest way to find out is just to ship. Let's actually build a thing, try it, see what works, see what doesn't work, and iterate and go fast. I think with a team of just, we've just, five of us right now, we can't afford spending a lot of time in design land or, simulation land. But we do know how to, build things quick and build things quickly, right? And, we're not just talking about like, let's just go and 3D print something and, hook it up. We're going and like, we'll come up with a design. We'll actually get it machined. We've already got like heaps of custom boards and custom embedded systems and everything done. We'll go straight to that. And sometimes things, they do work first time, and we've been very lucky in some places, and in other places things don't work first, second, or fifth time, and we just have to keep iterating. But with us, the way we work is, we don't let a failure kind of, oh, we have to spend like 4 weeks now investigating this and trying to figure out like what's, and we can afford to do that because we're not putting human lives on the line.
Right.
You know, what we're building these autonomous robots that are really low cost, and if you lose one of them, you lose one of them. It's fine. That's what they're designed for, and that's why we can deliver a platform that's really capable, really quickly, and at a really low cost.
Yeah. How long was it after founding that you had built your first robot?
But before we raised any money, we did do a prototype
Oh, cool.
that we used sesame seeds instead of seagrass seeds as an analog, and we
And
went
just
out
like a
to
bathtub or something,
no, we actually went out to Dublin Bay, and we
and just dumped a bunch of seeds in the
yeah,
water.
and
Nice.
we just had like GoPros, and then we filled up our little dinky little robot that this was 3D printed, and we put it around. Of course, it leaked straight away.
Yeah. Yeah.
Plastic bags, Ziploc bags for battery housings are not the most waterproof things. But we got enough out of just doing that over a weekend as almost like a side project, where we were like, yeah, maybe this isn't that hard. And then from there, we came out, raised a pre-seed round, led by Laura Carbon with Superorganism and Regen. And then very quickly we went from this dinky thing, this dinky, like not even hobby grade thing to, right, let's get first we started with the, simplest looking off the shelf ROV. We got that. We hacked it apart to see, how does it work? What's it doing? And what we realized is like, why is this thing so expensive? It's really simple, you know. A lot of there's nothing really that warrants this costing this much. And yeah, anyway, we use that off the shelf platform. We bolted our first planter attachment to it, and then flew to Australia. We've got some great partners out there in the University of Western Australia. We're doing the pilot project with them. Flew to Australia, did field tests. A lot that didn't work, obviously. A lot did work, and I think we disassembled and reassembled that robot 5 times in 5 days.
Yeah.
But then after that, we realized, okay, we have an attachment that could work, that can plant these seagrass seeds. Let's get a platform for it. And kind of this is where things really changed for us, because we first were like, all right, let's get this off the shelf ROV, and we can modify the frame and like
So in the early stages, you were just doing the attachments, basically.
yeah.
Oh, cool. Okay.
'Cause, we started with let's rewild the ocean and restore seagrass ecosystems on this massive scale, and that's still our main business line, and we've got a lot of traction, and we're super happy with how that's going. But in doing that now, we then realized like, hey, we want to carry like a dozen of these, to build something within a year that can plant what human-led restoration projects do in 5 years in a day, right? That's the kind of leap that we're looking to bring right from the start. And we realized like the amount of work it would take to adapt an existing platform to take our stuff is not that much harder to just build our own custom underwater vehicle, our own custom AUV.
It seems like it would be harder.
Yeah,
It seems like it would be way harder.
Yeah, that's what. But then the thing is, and this is where it's really like, the killer realization for us is the advancements that have made batteries so cheap, economies of scale from EVs and improvements in chemistry and yields, right? What have made smartphones so good and so cheap, these embedded processors that are super powerful, SIP power, and also things like accelerometers and gyroscopes, MEMS ones, versus, 20 years ago, to get something with half the performance, you're looking at, fiber optics that cost tens of thousands, and now you have this little tiny thing, tenth of a fingernail size, and that does the job. So you have that, and then like you got, I'm sure you've seen what FPV drones have done, both commercially and in places like Ukraine. 10, 15 years ago, the brushless motors for those were really, really expensive, not nearly as performant. Uh, and now you can get these like amazing motors that cost dollars, not even tens of dollars, but dollars. And then things like even the cost of like getting simple parts like machined or lathed, when you design something that is like simple and a tried and tested thing, like a propeller or something, it's, it's pretty easy. All that we had come across in our previous jobs. Me and Jamie both working at a drone delivery startup, Colin working in Formula One, and Dylan, our first employee, worked at a marine sensing company. And from that we realized like there's a lot of the same savings and the same tech that directly apply to this. And we just applied, you know. We started out with like in our first prototypes using like RC batteries, like, lipos that are like really high, watt hours per kilo, but low lifetime and low cycle count, but really high energy. And they were like pretty expensive. You're talking like for 5K you might get like 6 kilowatt hours of lipo, right? Which is like pretty expensive. Still a lot cheaper than a few years ago. And then it's like, okay, this is great for the prototype. We have gobs of power. Now we've characterized our power, and now we've doubled our capacity, and our pack is $500, right? We're just using EV blade cells, and they work. You know, all you need to do is put them in a housing that can withstand the pressures. And the thing is, we're focused, seagrass grows from like 0 to 30 meters. We don't need
Okay.
to go deeper than
Yeah,
that,
that's actually good. That's
you
like
know?
a yeah.
And using like, steel tube housings, even with just like, 3 mil thick walls,
That's
we
enough.
can go to 300 meters,
Nice.
even
Yeah.
with that,
Nice.
So,
That's so interesting. Is like the reason that no one else found that out, like the reason you couldn't buy something off the shelf was because the things are just moving so fast. Like much of the stuff that you talked about is really happened over the past 5 years.
exactly.
Like not even.
Yeah.
So I feel like if something was even designed 5 years ago, it's already out of date. You know what I mean?
I think that's part of it. Like there's a really low cost and really good off the shelf ROV that came out a couple of years ago. When it came out, it was a game changer, like super, super low cost, like, really capable, amazing. And they've even made a second version of it since. But obviously that company has like, they, launched that product. They don't want to come out a few years later and then, shrink their margins and their, their total revenue. So their new thing still costs like, in the same, same order of magnitude as the old thing. And I think you see a lot of that, right? You see a lot of that, both, commercial, defense, agricultural, everywhere, where you make a good product and then a lot of people are buying your product. And why should I make less money? Why should I drive the cost uh, down even more? And
I'm the only
that's
one
a
doing this. Like I have no
yeah,
incentive to do that. Yeah.
yeah. And that's just a massive opportunity for us.
That's interesting.
And
That's really cool. I mean, that's very much the lesson that that a lot of hardware startups learn from SpaceX, right? It's
yeah,
like, and even Tesla. It's like we just want to pull as much as possible in house because there's margin on top of everything, and it's like the idiot or what do they call it? The
the
idiot
idiot
index or
index.
something.
Yeah, yeah,
Yeah, it's like if you just calculate the value of whatever it is, the metal that you're machining,
yeah.
like the cost of that metal is so much less than the cost of the machined propeller. If you just go out there and buy a propeller off the shelf, so
hundred
if you
percent.
can learn how to make a
Yeah,
propeller, which like it's not a secret. Like it's
exactly.
not
It's
crazy.
not.
Then just machine yourself.
Yeah, yeah, and it's not even the propellers. Like one really cool thing is there's this. thruster design for submersible specifically. It's really cool. It's like it's not just a propeller on a shaft, but actually it's like a in-runner motor where the propeller is actually around the inside of the
Oh,
motor,
cool.
and then there's no shaft, right? What that means is like nets and stuff. It'll just fly right through.
Hmm.
They don't get caught.
It's like a
Uh,
Dyson bladeless
yeah, yeah,
fan.
yeah, yeah. Similar to that. And the patent for that expired ages ago. But there's no like crazy low cost version of it that you can just go off the shelf and buy. Of course, on AliExpress they have toy submersibles that somehow incorporate the design.
Classic.
Then we look at that and we're like, we could just get this. Like we can go and our motor supplier can supply the uh, the setter for this, and we make a custom rotor pretty easily. And now we've got this thruster that is cutting edge, won't get tangled, and costs, instead of $200 for a standard off the shelf, low cost thrusters, it's like $30.
That's awesome.
Yeah.
Yeah, I mean, so that okay, this gets perfectly into what I wanted to talk about, like what I teased in the beginning, which is all the requirements. So it's like, of course, cost is a requirement. Like you need to have this thing be as cheap as possible. The reason for that are sort of obvious for a lot of prototyping and like early startup reasons. You can't build $1 million like underwater vehicle because it's just going to be too much. You don't have $1 million or something. But it's also, I assume that like cost matters obviously. But what else matters? That's the big question. So what are the other like driving requirements that you think that you guys are uniquely awesome at? But then also like what are the hardest ones?
Yeah, of course. So like, yeah, cost matters, but cost is of course moot if the thing doesn't do a good job. And I think, two big challenges that like definitely make the marine domain so hard and set it apart from, air or land is, well, salt water and sand is like the most corrosive thing known to man. It's a horrific environment to work with. That, and then there's biofouling. There's all kinds of trash in the ocean, right? There's like, the remains of uh, sea life, plant life, and of course what we put in the oceans that we shouldn't be putting in there. And those two things present massive challenges, and there's no point in having like a really low cost thing if it rusts as soon as you drop it in, or gets taken out by the odd piece of trash in there. And that's like a key requirement is actually not just being waterproof. Like you have phones these days that are like waterproof and will turn on after being at the bottom of a lake for 2 years and being pulled out. But stories that are a lot rare are phones recovered from the ocean. After 2 years in the ocean or something like that. You do find GoPros and stuff that survive, but again, it's just such a harsh environment, and that has really informed like material choices and things like coatings and on all that. But the thing is, it's a solved problem. Boats have existed for hundreds of years, right? We've had submersibles for 4 decades, and we have people building houses and driving their cars by the seaside and getting hit with salt spray. So that's one of those things where like, yes, we unfortunately we can't buck the trend and cheap out there. But the thing is, those coatings and like choosing to use 316 stainless steel doesn't make our thing. That's not what makes these things cost 100,000 or 1 million.
What are the big drivers?
I think, well, right now the big drivers in cost you see are things like your sensing. Right. For us, we're in a great spot right now because we're targeting shallow water operations, and it's having like high fidelity ultrasonics and really good vision where the water is clear. We can do that at a really low cost. But
Those are the main sensors of depth is ultrasonic and then also just visual spectrum.
Those are two of the most important sensors we have. Then we've got a host of other environmental sensors, which again are way cheaper if you're using shallow water spec versions. As soon as you start going to like, past the couple hundred meters, and you're going to like 600 meters, 1,000 meters, or 2,000 meters, then the lens for your camera is like this thick
Yeah, exactly.
instead of just being this
Because of the
this thick.
pressure, just because of the
Yeah,
pressure.
just
Yeah.
because of the pressure. But then also your camera is trash because there's no light. Of course, the same in turbid areas, but also like you know your multi-beam echo sounder, which is like sonar based 3D imaging underwater. That becomes goes from being like a couple $1,000s to being tens of thousands, if not hundreds of thousands of dollars to operate at those depths and still give you high fidelity thing. But the thing is, there is so we have as humanity such little mastery over the oceans, right? And there's so much to do just in the shallow waters, right? So many things that having a low cost autonomous platform can solve, even just being able to operate between 0 and 30 meters.
Man, I have so many questions because I just don't know anything about this. That's what I love. I like there are a lot of people who come on this show that I actually like sort of know about their thing. This I know nothing about, like literally nothing. And so I think that one of the most interesting things you've said so far is about the different pieces of inspiration. So like some of the inspiration, some of the technology that makes this possible comes from like drones, like flying drones in
Of
the
course,
air.
yeah.
Some of it comes from boats, like the cool sealants and stuff like
Yeah.
that. Like, would you say that you're pulling from each of those sources of inspiration sort of equally, and like you're just taking, okay, we know that the batteries are really great from flying drones. We know that the, whatever, this piece is really great from boats. Like, are you trying to are you pulling from those equally, or do you find that it's really more like, okay, we're building a normal drone, a consumer drone, but underwater? Like, I wonder
Yeah,
what, yeah,
I think it's the way to look at it is actually a lot of the mechanics have to come from the underwater domain,
sure.
right? But a lot of the embedded systems, the sensors, the electronics, the controls is the same. In
Mm.
fact, easier in some cases. One nice thing about operating in water versus air is you're constantly in this incredibly well damped fluid.
Yeah, nice.
So, like with drones, we had to worry about vibration so much. That's just like it's actually so well damped that response time is the issue now,
Sure.
not not your
Interesting.
steady state. So yeah,
What
it's
about temperature? Because so like for space, like we build
yeah,
satellites, like it's the hardest thing. It's like it's
yeah.
so hard because you have
It's
to radiate
it's
everything.
it's so easy
Oh,
because we're
I'm jealous.
in the best coolant ever, seawater.
Yeah, that's
It's
awesome.
always so
Can you
even
just you can just mount anything that gets hot to the wall, and then it's just gonna like get all the heat out.
we just have to have thermal paths. That's it,
Amazing.
and that's like again because we are right from the beginning actually going and making custom housings, custom mounting, and I think people don't realize that can, even with if you have a little bit of money, that is easier and better than trying to shoehorn a load of off the shelf
Sure.
things in.
Yeah,
If
totally.
you actually just go and start making, even like yes, you can use a lot of off the shelf modules, and we did too. Well, we have done too while getting started. But even having custom back planes and custom brackets, then cooling's just not an issue for us. Everything
That
is
is
just
awesome.
heat sunk straight into the ocean.
So okay, I like ostensibly this is like a sort of beginnerish podcast or whatever. This I recognize, audience, that this has been a little bit more than that. Like people don't know what a backplane is. Like people probably don't know what housing is. Like do you mind like taking one step back and talking about the technical requirements that are easier or harder underwater, just from like a 101 perspective? Like so we talked about thermal. If you have the right uh way that you're organizing the like components within the middle of the thing, you can get heat out really easily. Like what are some other things that are easier or harder for underwater?
Yeah. So I think one thing which is way harder is comms and navigation. Um, Radio waves don't really penetrate underwater. How they talk to nuclear submarines is there's a plane that has a 6 mile long antenna.
This is one of the coolest stories. Do you want to tell the whole story about how this thing, because there's one in the air at all times, right? Like
Yeah,
they're just like constantly taking off and landing and
yeah,
stuff.
yeah, yeah. And so when nuclear submarine is on alert and waiting for orders, so it can never dive deeper than I think like 30 feet or something like that, and it's got to have this like super. It basically deploys this little like buoy that kind of floats up towards the surface, and that's its antenna. But even having an antenna that's like 30 feet long, it's still really hard to communicate with. So, said you've got these these planes that'll take launch from carriers. Um, they're very similar. I don't know the exact model. They're very similar to like the planes that they fly into hurricanes and stuff. Those the little quad turboprop things, and they've got these like I think 5 or 6 mile long um, antennas that just hang out the back and get like dragged along the water in some cases, and that is the only way they can send information to these submarines. And then you're thinking like, oh, like that sounds like surely they can send a decent amount of information. No, they're sending information at like a couple of bytes per second probably. It's like all they can send is basic text orders and like authorization codes. That's it. There's no way you're streaming video or having a conversation or anything like that. And then you have things like of course you have like uh, sound sonar based communications. There you'll see sound and light. There's like a lot of companies have made like optical modems and
Hmm.
acoustic modems
For underwater, I'm not aware of that. I didn't know
for
about that.
underwater.
Cool.
Yeah, and some companies have made really low cost ones, but the thing is like we're developing for our platform to truly be useful. Like it needs to be able to operate and like cover like hundreds of nautical miles. It can't just always stay within a couple of kilometers of the mothership. Then the utility's really not there. And that's all the range of the those low cost light based or acoustic modems are. um so that's a real challenge for us. um how do we talk to the robot when it's fully submerged? We don't. We put a heck of a lot of edge computing on it, and when you're planning the mission, you got to be really careful about having checkpoints, check-ins, and we've got some other really cool stuff as well. With we can we've got a solution that allows us to travel really fast on the surface and maintain comms for like the majority of like our travel, and then we can get to the point, and then we can submerge and hide or do what we need to do. So then you have that way you've got comms for most of the way, and you have until almost right at the end to like retask or change or send an update, and also like see what's happening, see what the drone is seeing. And then like the nice thing now is like there's a Starlink Mini
Yeah,
that fits right on the drone. So
that is
while
sick.
you're
Oh,
cruising near
really? On
this,
the drone? That's
yeah,
sick.
while you're cruising on the surface, you can like live stream all the data from the sensors and practically remote control it. That wasn't possible even 6 months ago, but now that can. And because we're moving so fast, integrating a Starlink Mini into our thing is
Yeah. I
super
will forgive
super
you for
easy.
bringing up Starlink in the home of another satellite internet. I'm
Well,
kidding. I'm kidding. They're awesome. That's so sick.
once you guys got your constellation, then
Yeah, that's you can give you a dedicated satellite
yeah,
for your drones. That'd be
there we
sweet.
go.
Uh,
That's the dream. But yeah, so like that's comms, and then the other thing is of course like the navigation. Right, you can't GPS underwater. Nope. And nuclear submarines and really expensive AUVs and ROVs all have like defense grade inertial navigation systems, which I'm sure you know about. Satellites use them, no doubt. These inertial navigation systems, the good ones really are still super expensive, and often quite big, but you do have like really low cost, like lower cost, like now in the four figures, where you have like like MEMS based INS systems. And then we've gone even lower cost, and we basically we have an acceptable level of drift, right? So to explain to the audience, inertial navigation is like, they call it dead reckoning. So it's like, imagine you just close your eyes and then you try to walk based on, kind of
the
knowing
number of
how
steps
far
you've taken
no
or
yeah
something.
knowing
Yeah.
how many steps you've taken, and like how far you've turned. And it's like almost like you're leaving breadcrumbs behind you, and you're just tracking how far you've traveled. You have to start from a known position, and then how far you've traveled. You're watching how far you've traveled from there. Uh, and with if you're using the sensors in your phones or a phone or something to do that, you'll very quickly drift off, um, because that technology is very highly controlled for a good reason. But we don't need to use the highly controlled technology and spend a ton of money. We can just bop up to the surface, get a GPS lock, correct the drift, and go back because we're operating in shallow water anyway, right? And then if we see the seagrass meadow, or we see whatever other target we have or anything, once you've got a visual lock on that, or a sonar lock on that, then you use that for navigation and tracking. Then you're not so much worried about the dead reckoning stuff, or what your actual GPS coordinates are.
The first answer really answers my question about why autonomous. Like, it seems like, okay, we're going super low cost. We're trying to make this as like cheap as humanly possible. We're trying to have these, prototype really fast. It seems like, why would you make the thing autonomous? That's like way harder. Like, of course, that is something that is a problem you wouldn't have had to solve if you just decided to like have some dude driving it with a joystick. But it's now obvious now that you said that. It's because when you're underneath the water, you can't be communicating with it as easily. So it would be very hard to have a person actually steering the thing, like, because you wouldn't have any way to know what the thing's seeing.
Yeah. Even now for our prototypes, like, we, when we need to, we tether them.
Yeah, totally.
And that's the only really cost-effective way to communicate
Yeah.
and debug
But
and
that
test
limits your
them.
range a lot. So like you wouldn't be able to have, you'd have to have all of your, what do you call the individual ones? Not the mothership. What's the other thing? Just the
The drones.
just the
Yeah.
drones. So
Yeah.
you would have to have the drones all physically connected via a big cable
Yeah.
back to the mothership, which
Yeah. And
dramatically
like
limits the range.
cables are big and heavy when you start adding up the length. So then, like, okay, even at that point, like, say you've got like a kilometer, or I've seen people do like 6 kilometer long tethers. That's what, like 3.5 miles, right? So 3.5 mile long tethers, and then, like, okay, you still have like 300 miles range on your craft or something, but you're only operating in a 3.5 mile radius. That's not really a lot of coverage. You don't have the utility that you get with having drones that can be deployed, hundreds of miles away. That is the level that you need to get to create a paradigm shift in marine operations, to be able to have a platform that replaces entire vessels at a fraction of the cost, right?
One thing I realized that we haven't actually talked about yet is the autonomy.
Yeah.
So let's talk about that. I'm curious how much of it is custom, how much of it is just like existing libraries that you guys were able to use. I imagine there's like a ton of detection stuff. There's a ton of route planning, optimization type stuff. Like, can you just tell us a little bit of like
Yeah,
what
yeah.
stuff you actually
So
have to have?
the,
And
the nice thing with like what we're doing now, and what a lot of ocean missions are like, is like pretty simple paths. Um, it's maybe even in some cases easier than in the air. Definitely a lot easier than on the road. There's no people, and nothing
Mhm.
else to really watch out for.
Mhm.
Most of the time, there are rocks and things like that. And things move a lot slower underwater
Mm.
as well. So you have a lot more time. Yes, I mean, reaction time is a lot slower too, but you still have a lot more time to really react and change. So that makes the whole autonomy thing quite a bit easier. And then the thing is, yeah, tons of it carries over from existing tech. Like, you're using the same type of controls as drones.
Yeah.
Um, you can feed it, object avoidance data, and target tracking data the exact same way.
Hmm.
It's the same libraries, it's the same code. Um, Obviously, what we're actually looking for and seeing and identifying, and where we're going, all that is different, and all that is custom. We have our own detectors doing the
Hmm.
work.
And your own
uh,
date collection to like feed into it, I presume, of
of
like,
course,
here's what
yeah.
these things look
Yeah,
like. And
a lot of the models don't actually exist yet, and so
right.
we're creating them,
Cool.
and we are actually making them. But the nice thing is, like, the models trained on that kind of stuff doesn't exist yet, but the models to do it do,
Right.
and they're really good. They're fantastic. So for us, a lot of it is just a data collection challenge, whereas the implementation is already super straightforward.
You just have
Uh,
to go take 1,000 pictures of here's what this bulb looks like or whatever, and that kind of thing.
exactly, right. You train the model, and then after that, the actual stack of having a good stereo camera, calibrating it to work underwater, and work in that lighting, and then having it draw the bounding box on the frame, knowing where that's in 3D space, and then feeding that to your controller. It's all the exact same way you do it on a drone.
Hmm.
And there's like a bajillion different open source libraries and frameworks to do that. That we're happy to build off and take and take and apply, and have applied, and they're it's working just fine. And then the other part of the autonomy that's like uh, kind of like different but also the same is how you do like a lot of the nav and localization is
Mm,
like different. You have sensors based on sonar instead of you're
sure.
using your GPS.
Yeah.
But the thing is, like, it's just a different input, but the actual like control loop,
Same
again,
idea.
it's the same.
Yeah.
Yeah.
Yeah, that's cool. I love the idea. That's a very interesting idea of about how you guys correct for drift by coming up and just resetting basically and like finding yourself again.
Yeah.
That's cool. Like, is that like a normal thing that a drone would do, or is
No,
that's pretty unique to you
so
guys?
the really expensive ones don't really have to do that because they can afford to put in this, and they also, I mean, when they're tailored towards like more sensitive applications, they don't want to do that. But for what we want to do and what we are doing, yeah, why would
Doesn't
we
matter.
not
You don't
just,
you don't have
yeah,
to stay because it's like you
yeah,
don't have to be stealthy.
yeah,
It's
yeah. But I mean, a lot of the hobby stuff and the lower cost vehicles, they do exactly that.
hmm,
Um, yeah, it works. It's a simple way to do things, and yeah, if we can afford to do that, why not?
that's awesome. So tell us about how you guys got here. I mean, it's not like a problem that everybody like wakes up and thinks about. It's not a problem that a lot of people know about. It's not a problem that I think most people. Um, I mean, at least like at first blush, it seems like a hard problem. It seems like a hard thing to go solve. And so like you had to be very confident that this idea was going to be lucrative enough, was going to be impactful enough. So like how did you know? How did you know that the effort that you had to put in was going to be worth it in the end?
Yeah, for us, like, even the seagrass alone, the numbers are insane. Like, it supports 20% of the world's fish stocks. 1 billion people rely on that.
Hmm.
Um,
But do
kilometers.
people pay for that? Like, do fisheries pay for that or something? Or
That's the thing. They don't pay for it, but once it's gone, all that value is wiped out. And they are realizing that now slowly, and they are coming around to protecting seagrass meadows, being able to restore them and put them back. Like, the European Union signed the EU Nature Restoration Law, where by 2030 all European Union states have to restore 30% of degraded ecosystems. And okay, 30%, you're like, oh, that's not a lot. That's like thousands upon thousands of hectares and hundreds of kilometers of seagrass meadows that need to be restored by 2030, and there's no way you're doing that with current manual methods. So immediately, like, that alone is a massive opportunity there. And as we've gone on the journey of building the robots for that, we've realized, like, wow, our ocean, as a civilization, we're really poor at utilizing it and getting, as much as we can out of it, and treating it as well as we can. And there's so little we actually know about it because it's so expensive, so manpower heavy, and just overall resource intensive to operate in. And because of that, you see things causing like massive economic loss. Greatest example is probably, like, one of the greatest examples is probably like the things like narco-subs, right? One of those costs the cartel 1.5 to $2 million, and carries sometimes billion plus in chemicals, or hundreds of millions at the very least in drugs. And I think there was an article I was reading from March, and so they've captured a lot of the low profile vessels, which are basically like boats that are mostly sunk, and they're like, just going along just underneath the surface. But there's a class of narco submarine called the fully submerged vessel. They've found a few of them in rivers. They've not yet interdicted one of them. They've not been able to. with all the resources of the Navy and the Coast Guard, they've not been able to do that. But imagine you had, um, you know,
Just a fleet of
hundreds
yeah,
hundreds of
totally.
motherships and drones, um, where the hundreds of them cost a fraction of a couple of cutters or boats. And these are things because we can actually operate underwater and we're not just above water, and because we can actually touch and not just look. Now you've got an actual net that maybe you will start catching these fully submerged vessels, and maybe you will be able to take billions upon billions of dollars, prevent billions upon billions of dollars of drugs from reaching U.S. shores, right? And that's just one opportunity there. Like another one, going back to the nature stuff, is like um, a problem with a lot of marine ecosystems, just like on land, is like overgrazing. For example, when seagrass ecosystems get overgrazed, and they have on a massive scale in areas like the in like Bermuda, um, you've lost your seagrass ecosystem. Your fish stocks are massively declining. A place like that that's heavily reliant on tourism, water clarity's gone, their sediment starts to shift around, carbon stocks are getting released, their water quality is reducing as well because seagrass actually filters a lot of water. But if you had a couple of motherships and a couple of drones on each mothership, you can you can deter these herbivores from overgrazing,
Hmm.
right?
Oh,
Just
it's just
like,
like turtles that are eating too much
yeah,
seagrass,
turtles
basically.
that, yeah, just like you have, on ranches, you have dogs that protect the cattle,
Hmm.
and prevent coyotes and mountain lions coming in and eating the cattle. The same way we could have our robots, like almost like
Just shove the turtles over to the side. Nothing to see
just
here. Yeah.
going around and just
Yeah.
scaring them off, and then you are actually safeguarding
Yeah.
hundreds of millions, if not billions, in economic value, and that actually allows the seagrass to recover faster as well.
Hmm.
And there's so much value to be captured there, and we're not even bothering.
Yeah, totally. That's fascinating. I mean, it seems sort of maybe obvious to me or whatever that the sea and the oceans are just these massive collective action or like collective what do you call that? It's like where you're all sharing the harms equally or whatever. It's like this big negative externality. It's like there are things that are definitely happening that are worth us solving, but because nobody actually like directly makes money from it, it's hard. So
Yeah,
it makes a lot of
yeah,
sense to me that you
it
guys are
is
kind of
hard, but the thing is, people are directly spending a lot of money on it.
oh
You
really?
know, one of the biggest examples there is, like, of course, the every single nation on earth has a coast guard.
Yeah.
You're right.
Yeah.
That is every nation spending ton of money to, and coast guards aren't just defense; they're stopping people doing illegal fishing and stopping people from dumping
Hmm.
uh, in coastal waters, and that they take care of all of that stuff, but they can't take care of it enough because they don't have the manpower. It's too expensive. And it's just too resource intensive. That's one thing. And then ocean, like, ecosystem restoration globally is like an $8 billion
Hmm.
market. So that's what's being, if you look at all the money that's being spent on mangrove restoration, protecting the corals, and kelp restoration, oyster restoration.
Hmm.
That's one thing, but then you're not even counting aquaculture, which is a massive industry, like oyster farming, fish farming, even things like, for example, scallops is like massive
Yeah.
seafood thing. A lot of money is spent on it
Hmm.
every year, and in many of the regions where you can get the best scallops, they can only be collected by hand by divers,
Hmm.
and that is really really expensive. And so a lot, there's not nearly enough of them being collected to meet the demand that's there, and that is a massive opportunity there that no one even looks at.
Yeah. I mean, it's interesting to me that I don't know anything about this. You know what I mean? Like I,
Yeah,
I think it's funny that like there's a lot of attention on above, like in the air drones. There's a lot of attention on autonomous vehicles for the ground, but like I don't know anything about autonomous underwater vehicles other than you guys. Like you're the first that I know. And you're saying that there was another. You said that there was another like sort of commoditized. We would call it a bus in spacecraft land, but like the commoditized frame on which you would put your payload, whatever it would be. Um, but does that imply that there are a bunch of these types of things? Like for the Coast Guard, does the U.S. Coast Guard have a bunch of drones today?
yeah, of course.
Oh,
They
they
they've
do.
got a they've got a couple of autonomous drones, and they've got the whole heap of ROVs. The thing is, every single one of them um, either costs millions, right? Not even hundreds of thousands, millions, and has to be deployed from a Coast Guard vessel and managed by a team of Coast Guard personnel. So, what is like? Yes, it allows them to go deeper and see things, but that's just like an attach. Right now, they're just attachments or tools. They're not the serving the primary mission, right? What serves the primary mission right now are the people serving and the vessels that they use. That's serving the primary mission. We have the technology. The tech has advanced far enough that we should be able to serve the primary mission much more efficiently. The same amount of people serving and the same amount of vessels, or even less vessels, supp- supplemented by a platform that can monitor the entire coast. Now you've got a well, of course I can never make any guarantees or say it's going to be impenetrable, but it could be a hell of a lot better for not a crazy amount of money. That's one thing in the ocean. And then the other thing is, like, yeah, it's undeniable there's a ton of spending in defense for and they have been spending billions on autonomous underwater craft for decades now, right? And they've been spending a lot of money, and they've acquired a lot of them, and they use them an absolute ton. And they have the money to do that. But again, they'll have an autonomous craft protecting a submarine pen here or a keypad zone over there, because they cost millions to tens of millions, and they'll only buy a couple. But if for millions to tens of millions you got dozens or hundreds of units, now suddenly you have something that could serve not as a tool but the executor of the primary mission.
Yeah.
And that's the
Hmm.
paradigm
Okay.
shift that we really want to bring.
And you guys are your bet is basically that not all, but like your bet is basically that these things are overspec, that they're made too expensive, that they're $1 million when they could fulfill 90%, 80% of their total mission if they were $1,000, ten thousand
Yeah,
dollars.
that's exactly it. We're like, for a couple $1,000s, or for four to five figure budgets, 70 to 80% capability is fine, because we can have 10 to 100 times more units.
Yeah. And so it's like the main requirements that are different between those super expensive and yours. One is depth, presumably. Like you guys just aren't building for
So
the super high
so
pressures.
it's depth, and those things are designed to have really, really long lifetimes and life cycles, right? Those are things where, like, oftentimes they'll be a research group will buy that and be like, we're going to use this for 20 years. Um, there's no need to use it for what we want. Having a life cycle of even a couple of years still makes it incredibly cost effective.
In satellites, the things that break down after time are like you get hit by radiation, which you definitely don't have to worry about.
Yeah, yeah,
You're under the water, you're fine. But it's also like, I guess like propulsion runs out, which you guys don't really have to. I guess batteries will degrade over time, so that's part of
yeah,
it.
of course.
But like, what are the other things that limit
Yeah,
lifetime
yeah.
for
I
you
mean,
guys?
all moving parts are going to degrade over time. Um, Anything where we actually interact with the seabed has to be designed as a consumable. Um, right? The sand, the rock, and the seawater. That's gonna wear away, really, really effectively. and to a lesser level, that will also happen to our craft themselves. Like, you can put anti-fouling paint on. That anti-fouling paint will need to be replenished every um every couple of years, right? So you have things like that. And then the other thing is, like, of course, what I said, biofouling. You know there's no way we can have persistency and not have a load of muscles attach themselves to our craft. And yeah, there will come a point where there'll just simply be too many for the thing to operate effectively. And yeah, it's a mix. Some things you can get around by going out and just doing the cleaning and doing doing the restoration work. But then the thing is, if you make the cost low enough, just put a new one in.
And you guys have done this with 5 people, is that right?
Yeah,
5 people?
five,
Five
five.
people.
Yeah, well,
That's
four for the first, just the co-founders for the first 6 months, and then we made our first hire in April.
nice.
Yeah, and
Awesome. So
he's a
how do you do that? That's I guess that means that each individual one of you has to own a big part of the vehicle. Like, so in your what's your specific
yeah.
discipline or
So
like, yeah,
I'm the one guy with the embedded systems and electrical expertise. So doing all the custom board design, all the power electronics, and then there's three other engineers, and they are all mech or mechatronic. So thankfully, they're not completely clueless when it comes to electronics, and they're actually pretty good and really helpful, and they're not afraid to write their own embedded code. And so that's great. But what they do all take ownership of and absolutely kill it at is all the various mechanical elements, right? We've got many things being developed at once, right? It's not just the vehicle and the platform and the mothership, but then we've also got the attachments for doing the seed collection, the planting, and the seed processing. And so each of them are able to own pretty large pieces of work each. And then one thing is, like I was saying, we're not afraid to just go and build things. And because of that, we're able to move really, really quickly, and you're not hamstrung by, like, oh, I'm the only person working on this thing and I'm not sure, should I do it this way or do it that way? Guess I'll just build the thing and then I'll know which way to do it. And I mean, we're 5 people, we all do a little bit of everything. you know there's you know I've done my fair share of mechanical testing. The lads have done their fair share of electrical testing and debugging as well. So there's a lot of that. And then of course I can't leave out Will, uh, our one non-technical co-founder. But we even rope him in for help testing sometimes. What better way for him to learn about the tech than get shocked by it a couple of times, or
there you go.
clamped by it.
That's
Yeah.
awesome. And you guys, so I presume you guys are going to grow a little bit from here because you just raised money, right? That was
Yeah, so we raised last year, and that has allowed us to get really strong commercial traction. We've got projects in Virginia with the Nature Conservancy. We're working with Florida State, their Department of Environmental Protection and Marine Laboratory, doing some work in Florida, and then we're working in Australia as well. And that's where we've got what we're dubbing Giga Meadow One
there you go.
coming up.
Giga Meadow. That's cute.
So yeah, we've got almost $1 million in revenue, so super super happy. We're really proud of ourselves for doing that. But to really deliver on what comes after these pilot projects, we absolutely have to grow the team. you know and yeah, I think by this time next year, hopefully there's 20 of us and not
Nice.
5 of us.
Is there
But
something that you guys like really want more than anything else?
I think right now, well, I'm the only embedded
Sure.
systems and power electronics
You want some
guys,
backup?
so I'd love a couple guys to help me out on that front. And then on the commercial front, we've been killing it in the seagrass restoration space, and like I've been talking about, we've become very aware that our platform can do so much more. And we want some killer killer go-to-market people to join us to help us capture the additional and well, spin up the brand new business.
So what's next? Like, what's the next 3 months, 6 months, 12 months, whatever it is? Like, what's the next like hardware revision that you guys are gonna do, and
Yeah, yeah.
how are you gonna get there?
So, like I said, just over a year ago, we had this dinky little 3D printed thing. And then, like 7, 8 months ago, we had our first like handheld robot. And then a couple of months ago, we had our first custom platform, this 2 meter wide autonomous drone designed and built by ourselves. Now, in 2 weeks' time, we'll be mating that autonomous. Well, we've already done it, but we will be deploying that 2 meter wide autonomous platform with our seagrass planting array. And we'll be doing one of the largest robotic seagrass planting pilot ever uh, in Australia, off the coast of Perth. So that's our biggest near term milestone, and then that's working with a species called Poseidonia. It's a big seagrass, and then in December we're out in Virginia working with a species called Zostra, much smaller seagrass, and we'll be doing the same thing there. Though because it's smaller, our robot with the same capacity is actually going to be much smaller. And so we'll at that point have two distinct platforms based on the same architecture, which is big for us because, our whole thing is like part of what lets us drive the cost down is not just all the advancements, but also we're modular and really, all our parts are rapidly interchangeable. And it's like, oh, this crazy new battery chemistry has come out that's way cheaper. All we need to do is redesign that module, right? And so we'll be proving our modularity works as well. Right, and that our architecture, our core electronics and power systems do translate across wildly different configurations. And then after that, we'll be looking at hopefully early next year deploying our first herbivory protection solution. And yeah, we'll talk more about that when the time is closer, but
Cool.
internally we're calling it RoboShark. So
There you go.
looking forward
Nice.
to that.
Nice. I love it.
Yeah.
Awesome, man. Well, thank you so much for doing this. Thanks for
Yeah,
coming
thanks
out.
for having me. It's great to be here, and yeah, really excited for what's coming next.